So today we have Suzanne first, talking about R2R, and then Adina will show us something about 3D printing, and then we have best practices. And Brandy may have already said all that. I don't know.
Yep. Thank you, Jules.
Take it away, Suzanne.
Okay. So I'm going to share my screen. Can people see the cover slide?
Yes.
Okay, great. So I have quite a few slides. I'm going to go through relatively quickly, I think. People can come back and click on things or review later and talk, but I just had information I want to get out. So R2R is a large team of people from many institutions. I think most of you know us. Jobs here are archiving, organizing, and disseminating the original underway data and documents that you collect. We do some data quality assessment and make some products and provide an at-sea event logger. Just give you an idea of the coverage that we currently have in R2R. This is the cruise data that you send in to us. So most of these red lines have data that is all available for free on the web to anyone. So we're looking at the volume of data here. And one thing I wanted to tell people that they might not have known is you can actually tell us the type of cruise. By default, it's a science cruise, but we do classify other types of cruises. So if you have that information, it'd be good to pass it on, because in instances, for instance, if it's a transit or a maintenance period, we know not to expect a data distribution to bother you. The gray line here shows the total size of data we received for that year. And it's been increasing pretty steadily, but it's interesting that last year, though we only received about half the cruises, we received more data than ever before. Some of these devices are really collecting large amounts. One thing that we want to think about is how fast do the operators get data to R2R. Once it's at R2R, it's going to be archived, it's going to be secure, and we're going to start looking at it and evaluating that everything's there. So the black line on this plot shows the weighted average for the number of days after the end of a cruise till we receive the data. And we're still looking at, as of last year, about 6 months, which means that most people send us the data after the entire year is done. So the last cruise comes quickly. The first cruise takes a year. It averages 6 months. So we're working, as you can see, there's some people sending data already from the 2021 season. So we'd like people to consider sending data faster, and we can help you do that. I'll have a bit of information on that later. Along with that, the cruise manifest, the information that tells us when, where, who for a cruise, is also taking about 6 months. Most operators send them separately from the data, and in some cases we need to go asking for them. But this is something that's part of the UNOL's requirement. They have a form to fill out, but if you have a standard form that has the same information, we're more than happy to work on harvesting it directly from that. And eventually it'd be great to use the MFP, but until everything's in place, we still have to use the old stuff. So how can you get data and metadata to us? We currently receive things via Globus, SFTP, cloud downloads from various systems, USB drives through the mail. Some people email, mostly cruise manifest, but smaller data sets sometimes come as mail. Dropbox, either one we share with you or one you share with us, and then other random methods. And we're certainly happy to try something new. So if you want to talk to us about different methods, we're happy to help. If sending you a USB drive to send back to us will make life easier, we can do that too. So get in touch with us, reach out, and we'll try to make this work so you can get your data to R2R and archive faster. So now I'm going to cover a couple of data issues. One thing, when R2R started, even though all the vessels seem to have a GNSS or INS system, most of them weren't sending. If you look at the green line in 2009, that was the number of raw navigation data sets we were receiving for the year. Whereas the blue bar is the total number of cruises, and the yellow line is the number of devices installed. So by 2015, we're doing pretty well at people collecting raw data, but there's still a few vessels that don't collect it originally raw, and we're having to harvest it out of other things. So if you aren't already collecting full resolution raw data, you should think about it, and we can talk to you. There's also here on this plot, the pink vertical bar is the number of cruise data distros, or data we receive for cruises. So we have a gap. It's gotten better since 2009, but not everything has a data distro. And we'd like to be able to figure out if it's because the cruise didn't collect distro, like it was a transit, or it didn't collect data, or if we're missing it. So we now have an operator dashboard that I'll show quickly in a little while to let you see what we have and don't have for your cruises. Okay, I have a couple here with lots of text. Sorry, there was nothing interesting to put on it. So recently we've been seeing some problems in the last 2 years with people either changing the names of their files, how they name their files, or their directory structures, or even worse, putting things like spaces, commas, special characters in the file names. So here are some suggestions for your filing name. First of all, don't change your names in directories, but if you do, tell us, because we need to do pattern matching to extract data. If we don't know it's changed, we just see it doesn't exist. Also, another suggestion is where people are naming things like the example here, where every cruise has a CTD 001 hex file. That means when the CTD data is all extracted from a cruise, they're all called CTD 001. And at best, you don't know what cruise it came from. At worst, you put them all in the same directory and only the last one exists. So we're recommending you do something unique like the cruise ID to prefix everything, or some ID so it can be maybe the date, but some way to keep file names unique, not only within a distro, within a cruise, but from cruise to cruise. Be aware, since NCI will only accept files and stuff that is Linux format, it means you have to be able to program and read on a Linux system the files. Otherwise, it won't accept it, so your data won't get archived. And that means these special characters matter. It means that if you change case sensitive from capital to small or random mixes up, it may not get extracted. And there's some other suggestions on this link. So next step we want to do is start collecting more documentation from the vessels programmatically like we do data. So some of the things we'd like you to start putting on or telling us about, if you already do, are any sort of technical or science reports, any sort of calibration or configuration documentation, like for the CTD, the PFPE laptop files, especially the GT, the gravity tie file, or if you don't use PFPE, the equivalent. If you aren't using an event logger, any sort of deployment information that would be useful. And if you are using an event logger, make sure that gets on the distro. And vendor documentations that help people know more about the make, model, software versions, any underweight flow devices, patch test information, and ship surveys, event logs, reports. The idea being, if someone 10 years or 50 years from now wants to use the data, we want to provide any documentation that'll make it useful to them at that time. Okay, so this is the operator dashboard. There's two ways to reach it. We're hoping to redesign some of our website because some of the most important things are hidden down inside other menus. But for any vessel, you can click on the link for your vessel, then click on the link for the year and see an image like what we have here to see, did we receive the data? Did we receive the metadata? Do we have the crew, the personnel manifest? How many data sets did we get? So it gives you an idea, and when you float over the little colored lamps, it'll explain why it was green, yellow, or red. So this, and we would like feedback on this as well. What makes it useful to you? Is there stuff we should add? Clarify. And then looking forward, we want to improve the search faculty functionality on the website and some organizational issues, extracting the documentation and serving that. We'd like to move forward with harvesting the cruise manifests from the MFP once that's all set. And one thing we're always trying to figure out is how to better exchange information about devices when they're changed, updated, taken on or off the ship, and do more with near real-time data streams to see what we can either for cruise metadata or actual data. And we always look for your suggestions on what you think would improve things. And we also are looking for someone to join our team at the Lamont campus. And we're kind of looking from two different angles. So it's one position, but we're looking at both someone that would be a PhD scientist level that has technical familiarity, or someone that would be a bachelor's degree with engineering and equipment experience that would grow into the position. So if you're interested, let us know. You can contact us or follow the links on this page to see the application and job descriptions. And here's some contact information. And we'd like to thank all the various funders. So I only had 10 minutes. I don't know how well I did.
Pretty well.
Okay.
What do you think, Brandy? Questions now or do them in the community?
Jim has a question.
It's not really a big question. It's a small question, and Suzanne can answer really quickly. First of all, great job. I mean, R2R has become the standard, the fleet in the world for what we're doing. So congratulations, you guys did great.
Thank you.
One thing, Suzanne, if you can do one dictate, I know you're reluctant to make demands, but if you could make one demand to all these people that are listening to you now, what would it be? Get your data in, get your formats right. What's one thing that you would tell people?
Well, my wish list is big. So what I would say today, what I'd like people to do is work on getting the data to us faster, because while it's on your systems, it might not be as robustly archived. I don't know what individual groups do, but once it gets to us, it gets archived at NCI and the Cave, so it's safe. It gets reviewed in case something's missing. We might be able to recover it before you clean your disks off or whatever happens. So that would be both the metadata, so we know a cruise is coming and it happened and we have it correct, which could be set out right at the end of the cruise, and then the data. And I have a much longer wish list, but let's just say that.
Sounds like a good choice. Ethan's got a hand up.
Ooh. Thanks, Suzanne, for your talk. I know that you've been working very closely with some of the folks at OSU RCRB for data presence. Could you comment just on where you see things heading as far as your work with them for the existing operators, as far as how we can improve our documentation with you, metadata, workflow, things like that? I know there's some things in the pipe. It might be valuable for other folks to hear about it.
So you're talking about the near real time aspect of it. Is that what you mean, or?
Well, whatever you want to talk about that I might not know about. I do know about, for example, like the XML metadata files that they're looking to do daily that will help all of us keep track of what sensors are installed on the ship at any one time, right. Things like that.
Right. So that is true. The information that they're doing where they're acquiring what's up and running, what's installed. And theoretically, that could also, like we were talking about, it could be sent to us while the cruise is underway. But the idea with a lot of what they're doing is we'd receive at the end of the cruise, if not before, what actually happened. One gap we have that we keep trying to figure out how to do is we don't know what instruments were collected. We only know what you sent us. So when equipment changes or is running or not running, it would be really handy. So that kind of, it's an XML, but other institutions might do it differently, would be useful to know. And so I know we can have a discussion or do something in the community, but
Yeah, we should probably move on.
but thank you, everybody. Everybody's been really helpful for R2R.
That's because we love you.
Thank you.
Adina.
Hi.
Hi, there you are.
Yep. All right, let me figure out this screen sharing business. And bring up my PowerPoint. So for those of you who don't know me, I am Adina. I work for the US Antarctic program as an electronics tech, and Brandy approached us to talk a little bit about our experience with 3D printing. So let me bring this up. All right, can everybody see that? There we go.
Yes.
Excellent.
Excellent. So so we have a couple 3D printers. They're a pretty fun tool. For those of you who don't know, 3D printing is a layer by layer additive process. So you have a plastic filament that is heated and extruded, and the extruder and the bed move relative to each other to form an arbitrary shape based on the G-code file or similar file that the slicer sort of feeds to the printer. And so, I mean, here's just an example. You have sort of a couple different stages. The first is when at the first stage, when the material is sticking to the bed, it's sort of a finicky stage, and then it builds up layer by layer to get your final product. The specific printers that we have on the Palmer, we have a Lulzbot TAS 5, and on the Gould, we have a Lulzbot TAS Mini. We did those with considerations for our space. For a while, Lulzbot didn't exist, and the last time I went to the website, they're back with some new products. So, but there are a number of different companies, MakerBot and different spots that you can get 3D printers. So we've been happy with these. I'm not endorsing this as a particular product. That's just what I have experience with. Things to look into is how fast does it go? What materials is it compatible with? How big of a volume can you print? And then other features like bed leveling. We found these to perform really well with the motion of the boat, whereas some earlier sort of less featured printers that we had a hard time with the bed sort of shaking around relative to the print head with the motion of the ocean. So getting something that's got sort of fairly robust steppers and that kind of mechanism is important to us. Another key thing for us has been how easy these are to repair, and they're well documented. So a lot of the parts on these printers are printed, and so we have printed up a bunch of spare parts so we can fix our printers as we go, and that's been pretty clutch to keeping them running. Oh, there we go. So I'm just going to intersperse a few examples of projects that we've used this for. So in this example, Kevin was making a bunch of battery packs, and it turns out the batteries roll around and it's really hard to hold them in place when you're welding tabs on. And if you print up a little holder to hold your batteries in place while you're welding tabs, you can bang out a bunch of battery packs really quickly. So there's a little widget that we made. Another problem that we've solved, well, repurposing pressure vessels for other purposes. So these have been great for making all kinds of mounting brackets and enclosures and things like that. In this example, we took a little GoPro and repurposed the deep sea and light housing, and needed to position the camera fairly precisely and keep it from wobbling around, so you could take pictures out of it, and use that to monitor some of our coring when we were having trouble with the multi-core misfiring. We've repurposed other houses to hold 9DOF sensors, so motion sensors, to look at wire wrap issues with our CTDs and things like that. So it's been a really, really great MacGyver tool to be able to repurpose things that we have, print the appropriate mounting brackets to get some really solid instrumentation together. I am lagging a little bit here. Let's see. Oh, there we go. So materials. The materials that you can print are plastics, and there are a bunch of different materials that are available. Lots of different considerations for choosing appropriate materials. So some of them are easier or harder to print based on, how evenly do they extrude, how hot do they have to get, how much thermal expansion is there, do they outgas? There are considerations for the mechanical properties that you need, what kind of environment they'll be in. So some are more or less good around water or UV, or organic solvents. And so there's a lot of information out there on choosing a particular material for a particular thing. So these are things to keep in mind when you're sort of stocking up, is like, oh, if I'm going to be printing a lot of things that I need to use with organic solvents, maybe I want some nylons and things like that. Whereas if I'm printing things that will get wet a lot, maybe ABS would be a good choice. And so choosing your material carefully for your application and is pretty important. And one thing that I found that has been really key for me for keeping the equipment nice is that there is an extruder cleaning filament, and that's really great when you're switching between materials and getting gunk buildup, and so being able to keep the extruder clean keeps the equipment operating well. Here's another example where for our towed echo sounder, we needed the deck personnel to be able to shut off the pinging and pull the transducers out of the water when we're approaching ice. And so we put together this system where there's a flashing light to alert the deck personnel as to when the instrument is energized, and this little wireless shut-off button. And so we needed to make cases that were watertight and robust and usable. So we could do fun things like printing these enclosures with magnets so that we could stick this flashy light onto the walls where it's visible, and a watertight enclosure using ABS and solvent welding for the button so that the marine tech can carry the button around in their pocket. And you can't see it on this photo, but on the far side, there's a little loop for a lanyard attachment so that it doesn't get lost. And so like on the topic of being able to print enclosures for things, it's great because you can integrate standoff posts, you can integrate all of the different pass-throughs that you need for the wires, and use different materials to get either watertight properties or to be able to heat set some screws in or other things like that. So very versatile, flexible tool. I feel like I missed missed the slide back here. So good and bad things about 3D printing. It's great because it's versatile. You can generate a lot of arbitrary shapes and a lot of things that are hard to do with like machining. There's a pretty good choice of materials as long as it's plastic. So it's great for all those little like this tiny little plastic widget in here broke and all of a sudden rendered this big piece of equipment non-functional. And it's such a simple little thing, but it's hard to do well. There are big repositories of models. So if you want a particular thing, somebody's probably already made it. You can probably download an STL and just print it out, go to Thingiverse or someplace like that. And the footprint of the piece of equipment is relatively small. So bad things about it, it can be really slow. This layer by layer additive thing is not the quickest thing to do. Some geometries are hard and you need to be able to use the computer programs to draw the things you need. And it can be really finicky depending on the material that you're working with. So like most tools, there are things that it's really good at and things that it's really not good at. I would say, you know, we found that there are a lot of applications where this is great because you're only using the amount of material that you need. So unlike starting with a piece and machining it down, you don't end up with all that waste. You're just doing the additive process. So that's nice. Lessons that we've learned, they're tools, they break, have spare bits and print backup parts as soon as you can. A lot of the printing is temperature and moisture sensitive. So having an enclosure and managing your moisture with your filament storage is important. Some materials outgas a lot, particularly ABS, which is a very common one. So in an enclosed space, this can be problematic. And it's kind of an art form. It's really fun. Be patient, experiment. And we've used it also a lot for morale. So this is one of the projects that I thought was just super fun, as one of our techs had lost a couple of fingers in a motorcycle accident much earlier. And so I found this parameterized printable finger that works and bends.
It's a little cockeyed.
So just to give an example of how complex of stuff that can be made with this tool, it's been really fun for morale. We've done things like we've done some other things like for people who have come and done some mapping. We've been able to print out 3D topographic maps of some of our study areas and other fun things like that that have been both entertaining and helpful. So that's just a little overview of a few of the things that we've been able to do with our 3D printers and a few of the considerations that we have. So if anyone has any questions. Yes, Brandy?
I do, but as the host, I can't raise my hand in the app. So I just wanted to ask about underwater applications. Like, I don't know are there gaps in the air gaps perhaps in the construction of these plastics that might not perform well at pressure?
So there are things that perform well at pressure. ABS is ketone soluble, so you can do acetone. If you give it an acetone treatment, it will fill in every little gap in there, and you can also solvent weld it with acetone. So that can make things that definitely have no gaps. Nylons print to be quite watertight as well. And there are printable gasket materials as well. So there are flexible materials that one can use to make like boxes that have a little gasket that will seal to be watertight. We haven't tested, I haven't made any enclosures for like doing fairly deep things. A lot of things, the standard printing practice is to have some sort of you have a wall and then a fill. So they're usually, without 100% fill, you do have air gaps in there. And so it's pretty slow and uses a lot of material to print solid forms. Okay, and let's see.
Max.
Yes, I just can throw in, we printed out some things very similar to that, little brackets and cable holders and such for our ROV, and we took them down to 5,000 meters and they survived just fine. I think it was PEK. I'm not sure.
Yeah, we've printed a lot of brackets for our CTD and things like that, and those have done fine. But those we sort of purposefully made sure that there were that there were places for the water to move in any place that might have an air, and wouldn't have air gaps for. So yeah, those have done fine to depth.
Ethan.
This is just more of a comment. First, thanks for your presentation, Adina. I got into printing a few years ago, first with an ABS printer. And in the last year, I've moved up to continuous carbon fiber printing. So a step above plastics. It's composite materials.
Yep.
So it's a mix of nylon with carbon fiber. And now I can make parts for structural applications. So I work with the engineering department to make things like packing glands and actuator latches. It's been a game changer. And I think probably in the next 5 to 10 years, we're going to see metal printing become more affordable and small enough to fit in the form factor of what we can do on ships.
Oh, cool. So does that have like some sort of a like sintering process afterward, after you've done the printing? Because that's the only like metal printing that I've seen has like a high temperature step after you finish.
Yeah, metal printing uses like a powder based material for the printing, and then afterwards you have to bake it in a scintillator to fuse all those layers together. So right now it's a large form factor. I think the cheapest one is like 100K, but from where it was a few years ago, I think it's just going to keep getting smaller and more affordable.
Cool. Thank you.
That's great. Is there a 3D printing community thingy that Brandy created?
There's a instrumentation topic.
Good enough. Good enough. Andrew had an interesting chat there about, I bet that would be a well-attended training session. All right, let's move on to best practices. Katie?
Yeah, hey everyone. Let me share my screen here. Can you hear me okay?
Yep.
All right. Here. All right. So hi everyone. Thanks for joining us today. We're going to provide you with an update on our initiative to develop best practices for seagoing operations. So I will start us off with who we are, a little history on how we got started, where we are now, and our goals for the future. So I wanted to take a moment and recognize our group members and working group leads. We're basically a group of like-minded individuals interested in developing best practices for seagoing operations for the U.S. academic research fleet, really developing, best practices for technicians by technicians. I did want to just note two folks on the slide here, Jay Perlman and Mark Bushnell, who are both part of the Ocean Best Practices System, or OBPS. You'll hear that acronym quite a bit, and who are really great supporters of our initiative. And then, of course, marine technicians, all of those who are a part of active working groups. Your contributions to these groups and sharing your knowledge with the community is so very important. And if you're not part of a working group, and you hear about what we're doing today and it interests you, then we encourage you to reach out and get involved. So how did this all get started? Well, a group of us developed the best practices for shipboard underway transmissometers and published it to the Ocean Best Practices System repository. This document was really meant to provide best practices to improve access to transmissometer data and metadata, as well as improve data quality. And I do want to just take a moment and put a plug in for Rebecca Hudak and Laura Stolp. They will be live presenting a poster today at 1300 showing results from Neil Armstrong in situ transmissometer calibration. So please go and check it out. I have no doubt it's going to be awesome. And then Shawn Smith, he gave a couple presentations on this document in particular at UNOLS and RVTEC, and it generated a lot of interest. And we thought to ourselves, well, let's use that momentum and see if we can't generate more documents for marine technicians. So with that, we presented at RVTEC virtual meeting last October. Mark Bushnell came and he gave a really great introduction into OBPS background and capabilities. And we introduced our group and kind of proposed our initiative for developing best practices for seagoing operations and really discussed why it was important. There's a lot of interest in the fleet and the standardization of best practices, leverage calibration funding, professional development, which is a really important aspect that I don't think we consider nearly enough for technicians, and the fact that you're the experts and it's important for you to share your knowledge and experience with the community. So what was our approach? Well, following our RVTEC, we compiled survey results and we had 25 responses. We held an initial meeting in February of 2021 to organize groups and identify group leads. And I'll talk about this a bit more in a moment. And at current, we have 5 active working groups established with 2 on the horizon. We're going to switch things up a little bit, and each active working group is actually going to give a lightning slide, a quick update on their status. So you don't have to hear me talk the whole time. But once these, documents are generated, then we hope to get them beta tested, hopefully through working with the tech training subcommittee, and then ultimately published to the OBPS repository. So there are 27 potential best practice documents that were identified by the community. And, just from the last, few days of listening at our RVTEC, it sounds like there could be a lot more. And with those 27 that we identified, there was actually, a ton of overlap with people interested in working on multiple different documents. So we kind of took a step back and identified and prioritized 5 groups to start out with. So we have the EK80 general flow through system, CTD profiler, SBE 43, and ADCP. Again, with those 2 on the horizon for the SBE 45 and wet start. So for now, I'm going to turn it over to our working group leads to introduce themselves and give a quick status update. And we are going to start with the EK80 group with Kristin Beem and Rebecca Hudak.
Thanks, Katie. My name is Rebecca Hudak. I am a co-lead on the EK80 best practice. Our first meeting was March of 2021. But since then, we've kind of taken a step back and a break because a lot of our members were busy during the sailing season. We had a lot of techs that were out and couldn't really contribute. So we decided not to push because this is primarily a volunteer effort. We have 17 active members that are contributing, including people from NOAA, UNH, OSU, URI, and WHOI. So we have a nice variety. Those are techs and scientists. Primarily, we decided as a best practice group to focus on calibration of the EK80, including a kit and what that would look like, as well as what features at the very basic can be run to get the best data. Of course, there's going to be a lot of other things in there, but those are our primary focuses.
Hi, hello, this is Shawn Smith from Florida State University. I'm leading the group that is working on the general flow-through systems best practice. We actually kicked off in September this year, so we've only had 1 meeting. The main thing I'm going to bring up today is that the scope of this best practice group is really we're looking at the flow-through system from basically the intake all the way through all the pipes, all the way up to the water wall, wherever that is in the ship. And looking at best practices for cleaning and placement of sensors and just any of those things that have to do with the system itself. We're not really addressing the individual sensors connected to the flow-through system. That'll actually be handled by individual best practice documents like the one for transmissometers that was brought up earlier. So we're basically just gathering our background knowledge and existing documents and starting to think about what needs to be in this best practice. The one thing that came up in the group, and if anybody's interested in joining, we'd appreciate having you, is we realized we may need some people that aren't just the technicians, but we need some people that are on the engineering side of the vessels for some of the plumbing and piping and that kind of stuff, as well as some additional science advisors. So we'll be meeting again, hopefully in November. So feel free to join us if you're interested.
Hi, I'm Laura Stolp. Rebecca Hudak and I are leading the CTD best practice. We started in September and we have decided that we're going to meet the first Tuesday of every month. So if you're looking for something to do the first Tuesday of every month, feel free to join us. There are hundreds of documents out there and we are currently working through a lot of them to see, so we're not redoing what's already out there and trying to organize and see what we have. We are working on organizing the different needs. We have people from science, we have the technicians, so everybody has a different look at the CTD data, which is really cool. And then our ultimate goal, I think, is to have it like a standard best practices for one of the ultimate goals is to have a standard best practices for the text so that to follow so that we can make a product similar across the fleet for all the CTD data that's collected, because there's a lot that we're collecting and QAing and DPing and sending off to World Ocean Database. So yeah, first Tuesday every month, join us.
I'm Gabe Matthias. I'm the Oxygen Best Practices Group Lead. We've got a couple baseline best practice documents already contributed by a couple of groups. And we already have a ton of supporting documentation similar to the other groups. Since Oxygen is used on CTDs, flow through, and in moored applications, we're in discussions with other we're in discussions with the CTD and flow-through groups to do some cross-pollinating, making sort of appendices where applicable. And if you're interested in contributing, we'd love to have you. We've got 16 or so people on the email list, always looking to add more. Our next phone call is November 18th. Please get in touch. Jules is next up.
I am. Let's see, I think we have 15 people in our email group. I was a bad lead and didn't convene any meetings at all, but we populated a Google Drive with a Google folder with basically people went out and Googled best practice ADCP. So there are multiple flavors of ADCPs. There's vessel mounted, which is what I care about most, lowered, and on moorings, and there are probably others, including ROVs or AUVs, I guess. Anyway, what this really did was catalyze me to put the best practices page into the UHDAS documentation. If this best practices scenario is limited to the academic research fleet, then we don't need to talk about VMDAS best practices, but we do have some VMDAS recommendations, and it's a work in progress. As the software gets updated on the ships, the best practices page will be there right up at the top of operations. And I encourage anybody who wants to click on a link here to go look at it and let us know what needs to be added. And I think we will work more together as a group as we move forward. Back to you, Katie.
All right. Well, thank you for all those updates. This is a really good moment to kind of give a shout out to our leads. This is, it's a volunteer effort, and this is a lot on top of their day jobs. So I just want to say they are all excellent cat herders, and I think these documents will be a really great value to the whole community. So big thanks to the leads. I did want to give an update on the Ocean Best Practices workshop that several of us attended in September. We provided an update to members of OEPS, and there's a lot of interest in our initiative and what we're doing. And there was a lot of discussion about how they might help support us. We discussed how official recognition could really help bolster our efforts. We also discussed how OBPS may host an endorsement panel for the best practice documents that we generate. At Current, they have a GOOSE panel, a Global Ocean Observing Systems endorsement process. And these are really for like science-based best practices. So we discussed what that might look like to have a technician-centric endorsement panel. Really, the endorsement of a best practice makes it just more visible to others. If it's endorsed, then it can be searchable by that endorsement in the repository itself. We also discussed task teams meant for reaching kind of short-term goals. One good example being decision trees. There's a lot of interest in the best practice community as a whole to develop decision trees, but no real, clear guidance on how to design a tree to be effective. And of course, that process is going to look very different between science-based and tech-based trees. So with tech trees, we really wanted to focus on these kind of time-based recommendations. So what can I do if I have 5 minutes versus an hour to work with a particular sensor? And then lastly, we discussed, how to promote international involvement. Right now we are primarily a group of US, academic research lead technicians with a few international participants, but, whether or not we should try to expand those efforts and promote more international involvement. So reaching out to MarTech and such. So we actually wrote 2 articles in the OBPS October newsletter that discuss decision trees and kind of promoting our initiative. And the link to those, to that newsletter is here on the slide if you want to check it out. I think I also posted it in our Hudak channel. And I just wanted to emphasize, OBPS is very enthusiastic about what we're doing and always looking for ways to help support our efforts. And it's really appreciated. Then I just wanted to end on, if you're interested, please get involved. Reach out to the lead of the working group that you're interested in joining. If you know someone who would be great and they may be interested, let them know. Always feel free to, contact me if you have any questions or comments, or if you just, like to learn more about what we're doing. And like I said, I've heard a lot of discussion this week about various, best practices that we might consider adding to the queue, for multi-beam and maybe even 3D printing or, LARS systems. So I think that, it's a great community, and the more that you guys can get information out and share it, the better. And I think we might have just a few minutes. If not, then, you can always interact with us on Huba. And again, thanks to our leads and all of the marine technicians that are involved in the process.
Thank you. Let's see. First thing, can you stop sharing so that we can see each other's faces? 2, Lee is back. Back to you, Lee.
Yeah, thank you. Yep, I've been listening for a while since I got back. No, are there any questions?
Ethan.
Yeah, thank you. Great presentation. Thanks, Katie. So in some of the things you listed, such as CTD profiler or ADCP, those are somewhat generic. They're not narrowed down on a specific type of sensor, let's say. So I'm kind of curious why with the oxygen sensor, you chose to focus on the SB43 and not look at oxygen sensors as a whole and compare, the plenum flow-throughs to like an optode, for example.
Yeah, Ethan, that's a great question. And, when we first started, it was how specific do we really want to get? So with the 43 in particular, we had some existing documentation that was kind of an easy place to start. With the CTD, it is really, and I think, Laura can talk about this a little bit more, but it is really focused on the 911 system and potential ancillary sensors that could be, added to that system. Did that answer your question?
Yeah, more or less. Since you ended on the 911, I wonder if you guys should be talking to Seabird, because I know they're trying to build the next generation of 911 and maybe they need input from a group like you.
Yeah, that's great. That's a great idea.
Ethan, you did give me an idea, though. I could refine the best practices, not refine it, but add a little bit of context having to do with what different frequencies are good for what. Thanks.
Yes, thank you. So Brandy, we're coming up against the 10 till. What are our next steps? We have poster. We said we have time for a poster session after this, but I don't see what's.
Yeah, that's technically, I believe, the end. of RVTEC officially. We have 2 live poster sessions scheduled this afternoon, as mentioned by Laura earlier, one by her and Rebecca. And we have another one by Emily Shimada, who will be talking about the Healy through the Northwest Passage, I believe. Tomorrow we have 2 training sessions. One with Alice for MFP cruise planning, which will be fascinating, and another by John Haverlack, who will be doing a demonstration and walkthrough, if you will, of installing his new IT asset manager tool that was developed this year. So both of those are look really interesting. They're scheduled for 2 hours. I think they might be more like an hour and a half. So it's a lighter day tomorrow, but I would encourage anybody and everybody to participate. They, as well as the rest of our meetings, will be available on the YouTube for the UNOLS website once they've gone through some editing. And that's all I have. Alice, do you want to say anything about the training tomorrow?
No, I think you did a good job right there. I do encourage folks to come, and I hope to not take 2 hours. An hour and a half would be great.
Jim?
I just got to say that every year y'all impress me more. I mean, with your enthusiasm, with your intelligence, and my gosh, you guys are the best. You guys rock. Technicians are fabulous. All I can ask is that maybe next year, hopefully we'll be live, but if we're ever in this 4-day long meetings where we got to sit all day, come up with something for old men's butts. Because man, this is a tough one after all these days. But all that foolishness aside, thank you all so much. You guys are the best.
We can ask somebody to print something for your butt.
That'd be good. Comfortable though.
Also, last plug, I just sent an email to RVTEC, but we are still looking for nominees for the RVTEC chair. If you are interested, please send me a very short message about your interest and something that we can share with the community for voting purposes. And if you want to elect someone else, let me know and I'll follow up with them and see if they're interested. But man, I think that's it. I think that's all RVTEC. And as Ethan said in the chat, let's have one in person, please.
Yes.
That means Jules is in charge now, huh?
Yes,
Jules, we're coming to Hawaii.
Yes,
Well,
sir.
Don't quote me.
I wasn't crying because I was in charge. I put the cry up because this is the end of the meeting.
Okay, y'all. Take care. Fabulous.
See you at the poster sessions.
Thanks, Alice, Lee,
Aloha.
Jim,
Everyone,
Brandy.
yep. Thank you.
Thank you.